For the next week, we're going to look at solving quadratics. Now, can anybody remember what is a quadratic? What does that graph look like?
No.
A parabola. What does a parabola look like?
Like a U.
A U. Well, unless it's upside down, but yes, a U. And as far as quadratics, what's my variable? X. X. That's linear.
Q.
Q. No, that's cubic.
Squared.
Squared. Very good. So x squared is my quadratics. So we're trying to solve these types of polynomials. When I say solve, I mean find the values for x that makes the quadratic equal to 0. As far as graphing, that means look for your x-intercepts. There are 5 methods which we're going to use here in this class. We're going to do the first 2 today. Method 1 is graphing. Normally that's the easiest method. Method 2 is use what's called factoring or the zero product property. Method 3 is the quadratic formula. Please note that out of all these methods, the quadratic formula is the only one that guarantees it'll find your zeros, no matter what they are.
All right.
Method 4, we will complete the square, which also runs into method 5 using the square root property. So all these have disadvantages based on how it's set up will dictate how you want to choose each method. Please note that you can always use the quadratic formula on every single one, guaranteed to get your zeros. Before we get there, we must know the golden rule. No matter what method you want to choose, your quadratic must equal 0. That's the golden rule. If it's not equal to 0, you have to move everything over and set it equal to 0.
Oh, I hate those.
This is the golden rule. Equal 0. Otherwise, the methods won't work. Quadratic formula is based on the fact that you have your quadratic set equal to 0. You'll get different results. Graphing is based on the fact that you're looking for x-intercepts, which has to be equal to 0. So speaking of, method 1, graphing. Its advantages, it's faster, it's the easiest method. We're basically graphing the quadratic and looking at x-intercepts. Disadvantages, well, what if those x-intercepts are radicals? What if the digit is 1.317654, etc.? It's kind of hard to see that x-intercept. And what if there aren't any? So I can have my xy plane, like so. And if you were to graph the quadratic, and it comes up here, tell me, what are my x-intercepts?
None.
There are none. But you do have zeros. They're imaginary. So graphing won't help you here if your quadratic is above the x-axis. Now, our steps in graphing are pretty straightforward. You want to graph the quadratic and then identify the x-intercepts. Seems simple enough, right? So if I were to give you this graph, what are my zeros?
Is that your hair time?
0 and 3. I'm looking at the x values of my coordinates, in this case 0 and 3. I don't really care too much about the y. I know the y is going to be zeros because I'm on my x-axis. 0 and 3. That's it. That's the zeros of my quadratic. That's it. Yeah. You just want to graph it. Once you graph it, look for your x-intercepts.
So you can put it in the calculator?
Yeah, so you can put it in a calculator, which is what you're going to do now. So go ahead and put this graph in your calculator and
I like this part of math.
find the x-intercepts. So those online, I highly recommend you use desmos.com, desmos.com. Also here, you're allowed to use this as well. Desmos.com is a graphing tool, and it's a lot easier to zoom in and out of your graph than a calculator. So here's my graph, x squared minus x, 11x plus 24. What are my zeros?
3 and 8.
Very good. They're 3 and 8. So x equals 3 and 8 as my zeros. By zeros, I mean I should be able to plug in these values here for x, and it should come out as a 0. So 3 squared minus 11 times 3 plus 24. That's 9 minus 33 plus 24. 33 minus 33, it is equal to 0. So I'm looking for values of x that makes this quadratic 0. And 8 will work as well. So that's graphing. The next method, some teachers say, is the factoring method. It's actually called the zero product property, but normally you have to factor first. So what is the zero product rule? That is, any number multiplied by 0 equals 0. So if I have a 0, does it matter what's inside my parentheses?
No.
What does this equal?
0.
0.
Is this
Its advantages, it's the fastest method if and only if your quadratic is already factored. The disadvantages is what? Well, you gotta factor. So what do I mean? So here's my quadratic, x squared minus 5x minus 24. It's equal to 0. So the golden rule is set. Now I want to factor this. It factors into x minus 8 times x plus 3.
Oh.
Now what if it's already factored? Well, using our zero product rule, what values for x will make this equal to 0? So I want to look at each term. So I'll look at this term first. If I can set this term equal to 0, then it doesn't matter what this is. It's all going to be 0. Likewise, if I set this equal to 0, doesn't matter what this is. It's all going to equal to 0. So look at each of your terms one at a time. So x minus 8. What value for x will make that 0? Not negative 8, but an 8. Just think of the sign and flip it. Just think of the sign and flip it. What's the opposite of minus 8? Plus 8. Or essentially what you're doing for each of these factors is you're setting them equal to 0 and then solve for x. X plus 3. What value for x will make that 0? A negative 3. If I plug in a negative 3, I get negative 3 plus 3, which is 0. And 0 times anything is 0. So my two zeros are 8 and negative 3. See how it's a really fast method if it's already factored? If you're lucky enough to have it factored, then you just basically read off 8, negative 3 by flipping those signs. Now one thing to note. You'll have to do this when we get into chapter 2, but I might as well bring it up since we're here. I asked you to factor this quadratic. We factored this months ago, right? If you had graphed this and looked at your x-intercepts, you could have taken these values and flipped them and put in factored form. Meaning, I have this factor. For what value for x, when I have x equals 8, will make this 0? Minus 8. For what value for x, when x is negative 3, will make this 0? Plus 3. So you can actually factor by looking at zeros and going backwards. Does that make sense? We'll have to do this in chapter 2. But since we're here. So if I give you, say my zeros are 7 and negative 2. What's the factors of 7? X minus 7. What's my factored form of negative 2?
Plus 2.
There you go. It's factored.
Oh, that's easy.
Yeah, well, these are, I'm saying hypothetically, these are my zeros. This is a factored form of that 0. This is a factored form of negative 2. And whatever polynomial this was, it's already factored.
But that's if you already have your
Right.
zero.
Well, if you don't, then you can always graph it and look for x-intercepts. That is if they play nice. They could be decimals and something crazy. So,
What?
yeah. We'll get back to that. I just want to bring it up. So here, find my zeros. Okay, so if I set this equal to 0 and solve for x, x equals 4. There's one of my zeros. What about the other one? X equals 1/2. Well, let's see. Set this equal to 0. Solve for x. Add 1 to both sides.
Divide by 2.
Divide by 2.
1/2.
X equals 1/2. So my zeros are 4 and 1/2. Yes, each factor, you want to set it equal to 0 and solve. Those are your zeros. So if I were to add one more, of course we wouldn't be a quadratic. What's my zeros for x plus 3? Very good. X minus 3. One more. Okay, so what's wrong with this quadratic? Before I begin, any method.
It's not set to zero.
It's not set to 0. So let me move that 30 over. Now I'm good to go. You may have graphed it, but I'm going to go ahead and factor this. So I'm looking for two numbers that multiply to negative 30 and add to negative 1. 5 and 6. Which one's going to be positive? Which one's negative? 6 is the negative, so the largest number here is the negative. So here's my factors. So what's my zeros?
6 and negative 5.
Very good. 6 and negative 5. Do we get that?
Mm-hmm.
Those are my zeros.